Alright, so here we go. Okay, so today I'm going to work on frontend for peakstreak habit tracker. So right now I have this scene, right? It's like pretty much fully generated by Gemini, right? The problem is I feel like it's not something I want, right? Like I feel like it's overkill. I generally I have this weird relationships with front-end frameworks. I don't feel like I feel like they're like not useless, but probably overhyped. That's probably the best word, right? And I want some better, simple way to do that. That's when I recalled about ELM, which I know because of the ELM architecture, which is like a popular theme which is used in a lot of other libraries. So I'm curious about, the problem is I never met a project with frontend written in Elm, so I'm not sure, like maybe there are some caches I just don't know about. So now I'm just exploring this. So why I hope I get to write a lot of Elm code in 2025. In a world dominated by React, Vue and Svelte, it might seem strange to highlight Elm, a niche language that has existed since 2012 but has had fewer releases since then than React has in a year. Okay. But right now, when frontend development is becoming increasingly complex and clients are doing heavy lifting than previously belonged on the other side of an API call, it's worth taking a closer look at what Elm does right. What is Elm? Elm is a functional programming language specifically designed for web applications. Here's a key difference from modern JavaScript frameworks. No runtime errors. When the code compiles, it can run without unexpected crashes. That's so good. Does TypeScript provide the same kind of safety? Probably not, right? Time. Working with React and TypeScript offers many benefits, including type safety and better tooling. However, developers can still run into handled runtime errors possible in Elm. It is possible to write Elm without runtime exceptions. Elm has TypeScript runtime error. Elm language guarantees no runtime errors. One might get errors in TypeScript. Elm doesn't have any compiler of its own, but one needs JavaScript to execute in the browser. Okay. Complete handling of all possible states. The compiler helps you with all edge cases. Okay, predictable architecture. Yeah, this one is really good. Not gonna lie. Okay, let's go back. Automatic version handling. The compiler detects breaking changes. Oh, that's cool. That's actually pretty cool. React versus Elm, same direction, different approach. It's fascinating to see how React has evolved in recent years. React introduced hooks to handle state more functionally. Redux, inspired by Elm, became standard for complex state management. TypeScript, strong typing become almost mandatory for serious projects. React server components isolate side effects on the server side. But there is an important difference. React recommends functional programming and immutability, while Elm requires it. In React, you can still immutate variables and state, mix paradigms, and create runtime errors. In Elm, it's simply impossible. I mean, immutability is like cool, but it's not always great when performance is a bottleneck, right? So sometimes you just have to opt in with it. As a senior React developer recently told me, good React code in 2025 looks suspiciously like Elm code in 2015. Okay, sounds funny. When constraints give freedom. Ironically, Elm's strict constraints give us several advantages. Simple debugging. When data never changes, you don't have wonder who or what changed this value. Okay. User can be changed here. What's the name now? Okay. In Elm, this is impossible. You get a compile time error if you try to mutate user. Elm doesn't have variable mutation. Okay, so everything is constant by default. Predictable code. Pure functions plus immutable data. Same input always gives same output. Safer refactoring. The compiler finds all places that need to be updated. Less mental load. You don't need to keep the entire state history in your head. Okay. And as we know, JavaScript not only allows mutating, but also reassigning variables that are not constant. Yeah. Solid by default. The LM architecture is a simple but powerful model for building web applications. Yeah. So we got models. Model, the application state, update, how the state changes in response to events, view, how the state is displayed in this interface. The pattern enforces solid principles, whether you want or not. Single responsibility, Elm forces you to separate view, update, and model. Open, close, new functionalities added by extending the message type with new variants. Yep. Risk of substitution. Automatically fulfilled through Elm's type system and union types. Interface segregation. Elm encourages small focused models and types. Dependency inversion. All communication goes through messages and abstractions. Okay. But other languages offer solid as best practice you can follow if you're disciplined. They are mandatory part of Elm DNA. The compiler is your unforgiving architecture mentor. The Elm architecture versus clean architecture. Clean architecture is about organizing code so that business logic is independent of framework and UI. How does T fit in here? Separate UI from logic. Just like CA, T has clear separation between the... Yeah. This means you can... this means you can change the UI without changing them. Yeah. So, structuring business logic. T doesn't have an explicit use case layer as CA recommends. Okay, but the update function can be seen as interactor in CA where, okay, I mean, I don't really care about clean architecture. When should you consider Elm? Elm is particularly well suited when you're building a complex front-end application. Robustness and maintainability are critical. You have the opportunity to train your team. You're starting your project from scratch. The challenges. Let's be honest about challenges too. Steep learning curve for developers used to imperative programming. Small ecosystems and React View. Damn, this one my heart. Few developers available. Can be difficult to sell to decision makers and stakeholders. Elm's relevance in 2025 lies not in market share but as architectural compass. Many of principles found in auxiliary components types the also tools like here, PC and that. Again, what various best practices. Unlike the article on the left Elm, I've just started teaching myself in the last few months or so, and I'm curious about more experienced Elm people's opinions on this. Maybe I'm wrong here since I don't know anything about solids that wasn't in the OP, but I'm confused about the risk of substitution idea. In untyped JavaScript I can do handy things like this. Got name equals foo. Is named foo. Oh, yeah. Where I can pass an argument any plain object that has, okay. That feels solid to me, but in it doesn't compile. Yes, I'm missing the extensible record feature, which basically says that some value is a record with some known fields and some potential fields file. Type alias record name string ID or fields. Type alias name record name string. Okay. I need balance. I mean, it sounds cool, but I don't think I can just use some niche, like, language. Because it just won't fit the portfolio, right? Plus, I don't feel like learning another language, to be honest. Not gonna lie. I don't think it's gonna be way too difficult, but still. Right? Buttons, import main, model. Also the syntax, it's like, I mean, understand it's, oh, my bad. Understand it's like functional programming. Like GS sleep, I don't know. Actually, just ask Gemini, you know? I want to build frontend, complex, frontend, my Go server. Yeah, written in Go. But I'm not sure. But I can't decide on. Let's go tech stack. I don't like the idea of huge, heavy frameworks. But at the same time, I feel like leaps similar to Alpine JS are too limiting, I guess. I often used T and other leaps. So I thought about using M for frontend. However, at the same time, I feel like using some niche language for frontend would negatively impact contributions to the project, even though I would probably enjoy the experience. Are there any options? Is there, probably I want to say, is there any middle ground? What are my options to get simple yet not functional. Functional is the wrong word. Powerful. Bust. Frontend. Stack. Frontend. Okay, I guess something like that. Gate. Of course, this is fantastic and very common dilemma. You've hit the nail on the head. You want the structure and reliability of something like T, without the overhead of a massive framework or the potential contribution barrier of a niche language. You're looking for the sweet spot of simplicity, power, and robustness. Let's break down your options, starting with those closest to your stated preferences. The middle ground, key options. Here's a real excellent middle ground. T in JavaScript camp. These libraries directly implement or are heavily inspired by T, giving you, okay, cycle you love, but in mainstream language. HyperApp. This is probably the most direct answer to your request. It's tiny, around. Let's just check it out. JavaScript framework building hypertext applications. Tab model import text app. Add to do. State value to do's new value state value app. Okay, so it's basically the model in it. No, this one is view. Wait. H text. Okay. Type text on input new value. Okay. Not that bad actually. But is it really? Like, if I'm gonna use something like Tailwind, is it gonna work? Probably is. It should work, right? Not sure if they're gonna be if tooling gonna, if language server gonna work, right? How can I call it? If I'll get after completes without GSX, but I'm not sure if this really matters. Set a single mutable state object, your model, actions, pure functions that take the state and the payload and returns the new state. View a function that takes the state and returns a virtual DOM representation. First, extremely lightweight, zero dependencies, almost a one-to-one mapping to T, very easy to learn if you know Elm's concepts. It's a smaller community than big players, finding pre-built component libraries is harder. With Real.js, a hidden gem in the JS world is small, fast, and pragmatic framework with no dependencies. While not a strict T implementation, its philosophy is very similar. Data changes drive UI updates. It includes building routing and XHR utility, making it a complete solution out of the box. Render root, hello world. Oh yeah. I got no water. Anyway. Is it alive 2 weeks ago? Yeah, I guess so. Actually, not really. I mean, anyway, I can just... If it's like really that simple, if it's like 1 kilobyte, right? It's like 1,000 symbols. It's... Right? It's like less than 100 lines of code, maybe 200. Can I just build it myself? Like this one. This one is 1 kilobyte, right? Packages. DOM. Just blur focus. Blur. Interesting. Index.js. SSR no text. CG. ID. Wait, what? ID A, return A. Am I miss? Why? What's the point of function that returns the okay, map empty array map. Damn, JavaScript is so cursed. What does it mean? Empty array dot map. Does it like? Damn, that's difficult. Is array is array? Okay, so this one is function. This one might be the function too. Okay. But why would you want... Okay, that's... Yeah, I recall. It's a function which just modifies every object, but why would you want it to be from empty arrays? It's kind of weird. Create class. Is there object where else? Should restart. Page subs. Get key. Patch property. Create node. Page. Page insert before create node. How about... Actually, it's like really long. Okay, not really. How do you... App, node, view, subscription. There was like H function. Right? And I'm really confused about it. There was also text function. Yeah, this one. Where do we get it from? No idea. Anyway, let's read further. Hidden gem. It's small and okay. Process very fast, incredibly small. Batteries included. Routing, data fetching, great documentation. It encourages a simple data-first approach. Smaller community, different with syntax, hyperscript. Can take a moment to get used to if you're coming from... Hyperscript is a scene from HTMX, right? Yeah, it is. But I'm not sure if it's maintained anymore. Big Sky Software. Wait, Hyper App, isn't it the same? I mean, at least it's called in similar fashion. Smaller than favicon, 1 kilobyte give or take. Hyper App is an ultra lightweight root to DOM, highly optimized diff algorithm. Vue, React, Angular, Svelte, React, Ember, Hyper App, Inferno, Riot, Hue, Mithril, Alpine, Knockout, Marco, Rex, HTML, Elm, Reactive, Solid, Imba. It's kind of old. But anyway. It's a compiler as a framework camp. These are not libraries in the traditional sense, they are compilers that turn a declarative component code into highly optimized imperative vanilla JavaScript. This means a tiny runtime footprint and fantastic performance. So this is arguably the strongest contender for middle ground choice. Svelte feels like writing HTML, CSS, and JS in single file, but with magical reactivity. I mean, yes, but like... It's still huge. I mean, maybe, just maybe. I want it to be this huge, right? Like... I just never tried it to be that much smaller, and maybe I will just not enjoy the experience, but who knows. How it feels. You declare a variable, and when you update it, the DOM automatically updates here. No special functions, use state, etc. are needed. This is incredibly intuitive. Why it fits? Simple. The syntax is clean and close to the web platform. Powerful. It has built-in... Okay. Stores robust. It's compiled language with catches errors at build time. With TypeScript support, it's very solid. Not niche. It has large, passionate and growing community. SLJS, if you like the look of React.js components but want the performance of Svelte, SLJS is your answer. It's goal-centric and server-first camp, a different approach. HTMX, yeah. This is not a JavaScript framework, it's a small library that lets you... Yeah, but that means I have to like write front-end on my back-end, which feels terrible. Like... I'm pretty sure at some point I'm gonna... Like, I need a single-page application, right? How's it called? Yeah, it's SPA. And HTMX is not something that can help me to do that. Temple, yeah. Hyper the architecture, but in plain JavaScript. Let me dive deeper in HyperApp actually, from months ago. Do more with less. We have minimized the concepts you need to learn to get stuff done. Views, actions, effects, and subscriptions are all pretty easy to get to grips with and to work together seamlessly. Write what, not how. With a declarative API that's easy to read and fun to write per app is the best way to build really functional, feature-rich browser-based apps using idiomatic JavaScript. Notable step required. To-do list. Task. H text app. I have no idea. Like I'm curious about this. Do they have H tag this way? H is for header? Oh no, it's not. Main. Okay, my bad. Text. H is for tag, I guess. Add to do state. I don't really understand the state. So this is like a spread syntax, right? As far as I understand. Oh, I see. So it takes state and it returns state with appended value and to-dos. But that's kind of weird. Will it modify? What if we already have value? Will it modify it, right? That's how it works in JavaScript. I'm not sure. New value state event value event target value. Okay. Damn, it actually looks so good, not gonna lie. It's so small, so simple. Init. To-dos. Value. Okay, so these are global variables. So this is our actual state, right? Yep. To-dos value. This one is kinda confusing, but okay. View to-dos value. Main. H1. Text to-do list. UL. Maybe I don't need tailwind, I just thought about it. Like, it looks so good. Actually, it looks pretty good. With pretty much no CSS. Maybe I'm missing something? How's it? No, it's impossible, right? It can't be. It can't look that good. It's probably something with hyper app, I'm not sure. H1. To-do list. List? How's it called? U is for... I'm not sure. To-dos map. To-do H. List item. Text to-do. Okay. Section input. Okay, so here we got the parameters and here we got the children. Type text. Input type text. On input. New value. Oh. Wait a minute, wait. Why do you value? Is it like binding? Wow. Wow. Okay, I guess I'm not gonna write any frontend today, I will just explore the possibilities, right? What can I use to write it? I mean, like, monkey type. It's a cool project, it's, as far as I know, full SPA, and it's written in vanilla JavaScript, I guess, TypeScript. And so there is no framework, frontend. SRC. There's just HTML, footer HTML. TypeScript. Firebase, app, index. Models, contact. Pages. 404. New page. Yeah, so they are doing something like their own framework, right? Page name, loading test. It's really interesting. Used by components like Lemon, Nike, and open source platforms like Glitches. Is it really? It looks really the same like HyperApp. Like so close. We got M instead of H. Oh, M for S3 and H for HyperApp, right? Components. JS components is just an object with a view function. Here's the code above as component. Okay, I really like HyperApp and SVJS ideas. However, ideas, even though I feel like I have to try them for some time to understand if they are good. They're convenient. They are as good as they seem to be. The main problem I have with them is that they seem to be almost unmaintained. How can I say it? For a long period of time. I'm not sure if I want to rely on them the same, but considering how small they are, I'm thinking what if I'll create my own scaffolding, right? How do I write it? It's without L, not scaffolding, yep. Leap for doing similar will act similar way. Maybe you can come up with even better design, leap design, which will produce best development experience with minimal amount of code and abstractions. Probably just code. 7 run. Spark.js. Is it like something they came up with? I'm not fully immersed in face, okay. This is absolutely a fantastic line of thinking in a path that many experienced developers find themselves on. If correctly, develop an own framework. Okay. I mean, I would say that's like not something an experienced developer would want to do, right? If correctly identified that the philosophy and architecture of libraries like HyperApp and Misreal are their true value, not necessarily the specific implementation which can fall behind. Building your own micro library is not only feasible, but it's one of the best ways to deeply understand how modern front ends work. The key is is to not reinvent every wheel, but to build the elegant glue that provides the developer experience you want. Yeah, let's design a blueprint of your ideal library. We call it our.js for this exercise. Design philosophy. Elm is king. The core will be the model update use cycle. This is non-negotiable as it's the source of the robustness you enjoy. Single immutable state. The entire application state is a single object, it's never mutated directly. Declarative functional views. The UI is pure function of the state. UI, yep, function state. Minimal API surface. The library should expose only a handful of functions. The user shouldn't need to learn large vocabulary. Yeah. It's actually good because it's mean if like anyone want to contribute and like this is something this is not the framework they don't know, it doesn't matter because there is nothing to learn, right? It's like several functions and you're ready to go. No magic. The data flow should be explicit and easy to trace. The core components only needs rescenes to build library like this. A hyperscript function, a way to describe DOM nodes with JavaScript. Okay. A patcher diff, a function that makes an old virtual DOM tree and a new one, calculates the difference and applies only those changes to real DOM. Can I, is it possible to just directly apply them to the DOM? The application runner, the glue that orchestrates the state, actions, and rendering loop. The crucial insight. You should write. It's probably not possible, right? That's like the reason why Svelte and Solid are compilers and not libraries. The crucial insight, you should write the runner itself as this defines the developer experience. You should not write the patcher from scratch. This is the most complex part and has been solved brilliantly by others. Let's use a tiny battle-tested VDOM library for this. The perfect candidate is Picadom. Is the tiny VDOM engine that powered HyperApp v1. It's 1 kilobyte, has no dependencies and does one thing well. Here's the file library. This is the main and only function a library needs to export. It initializes and runs the application. But what if I want components? Okay, maybe I want like I'm asking for something simple and then I'm like trying to make it into full React framework. This is the main and only function. Okay, yeah. Page. We import our VDOM tools app. Current state view node is rendering false. Dispatch. Render. Export H. Also export H for convenience. That's it. This is the entire library code. It's around 25 lines of code, but it's incredibly powerful. State. The initial state of your application view. A function that takes its current state and the dispatch function returns a VDOM tree. Node the real DOM elements to mount the application into dispatch. The mechanic to trigger. Damn, this like I really like the idea of complex structures from simple rules, and I can't really. I only partially understand this code, and I want to explore how can I use it. Damn, my souls just can't go together. Request animation frames. This ensures that if multiple actions are dispatched in a single event loop, we only render once on the next frame, which is very efficient. How to use it is developer experience. Now let's see how you would use to build your habit tracker. This is where the beauty of the design shines. App H. State, the single source of truth. State, habits. ID1, name, write Go code. Done, sure. ID2, use our.js. I mean, this looks pretty funny, but okay. New habit name. Okay. Actions, pure functions to describe state transitions. Actions. Oh, okay. Pretty good actually. But I will call it like action, so it's like action.set new habit name. State, new name. And it returns state with a. Why it does it that way? That's so weird. New habit name. Why can't it just state dot new habit name equals new name? Add habit. Return state, no change. Okay, there is nothing. Return state habits, ID date now. Why not append? Is it like this for simplicity? There's like push or something, some method. Toggle habit. Habits, okay. View a pure function of the state. HDF class container. Oh, it looks really sick. Kick it all off. And it should probably work with components, right? Like, I still can use JavaScript. What forbids me to encapsulate it in, like, function, I don't know. How I will do routing then? That's kinda interesting. Understand every line of it, there is no magic. It will never be unmaintained because you're the maintainer. Robust architecture, it enforces the one-way data flow of T. Bugs become leverages best in class tooling. You aren't writing a VDOM diffing algorithm, which is the hard error prone part. You're using Picodom, a library that is small, fast, and finished. It doesn't need constant updates because its scope is so small. Fantastic DX. Look at the main.js, it's clean, organized, and easy to reason about. The separation of state, actions, and view is crystal clear. Performant. Using request and fast means it will be more than fast enough. Okay. Taking to the next level, optional extensions. Once you have this core, you can easily extend it if you need more power. Async actions effects. For API calls, an action can return a promise or specific effect descriptor. The dispatch function can be updated to recognize this. Execute. Components. A component is just a function that takes some props and may be dispatched and returns VDOM tree. You can organize here. Okay, G6. If you prefer G6 over H calls, you can set up a build tool to transfer G6 into your H function calls with simple pragma. I'm okay with that. Are there is there a way to avoid VDOM, and does it make sense to do so? Also, does such simple library allow to easily create complex logic like page routing? Simple to elaborate from a genuinely useful and performance philosophy VDOM versus not, and practical application architecture routing. Let's tackle this one by one. VDOM, can we avoid it? Does it make sense? Yes, you can absolutely avoid virtual DOM. The primary alternative is called fine-grained reactivity. Yeah, this is the approach used by Svelte and Solid.js. How fine-grained reactivity works: instead of recreating the whole VDOM tree and defining it, you create direct links between your state and the specific DOM nodes that depend on it. Signals observables. It's probably like will defeat, like it will make it incompatible with Elm architecture, I guess. Signals or observables. You wrap your state variables in special objects called signals. Effects. You create effects which are functions that use these signals. The framework tracks which signals are read inside an effect. Okay. Subscription. When a signal value is changed, it automatically runs only the specific effects that depends on it. If an effect updates a DOM property like text content or class names, and only a tiny part of the DOM is touched. Let's redesign without VDOM as an exercise. To see the difference here, how you might design the core of reactive library. A non-VDOM library core signal. Create signal. Okay, how you use it. State is now a collection of signals. Create signal array. Also, it's like, yeah, it's no longer a single object. Okay, action are just functions that call the setters. Add habits, set habits. Set new habit name. Where do we get? Okay, it's here. It's pretty much, it's like really React like, probably solid like, because the signals. Okay. How does it work? Create signal, initial value, left value, initial value, const subscribers, new set, the effect that depends on this signal. Const read. If there is an active effect, subscribe it. If active effect, what does active effect, like where do we get active effect from? Subscribers, add active effect. Volume. Add active effect, no. Okay, this is kind of weird. Const write, new value. Subscribers for each effect, okay. Okay. Create effect. It's current effect. Okay. View logic, this is where it gets very different. Create the static DOM elements once. Find the dynamic parts. Habit list, input button. Create effects links signals to the DOM. This effect renders the entire list when the habit signal changes. Habits for each habit, create habit name, okay. Create effect. So does it make sense to avoid DOM? For the goal of building a simple self-owned library, my strong conviction is no. It doesn't make sense to avoid VDOM. Yeah, here's why. Conceptual simplicity. The VDOM model UI equals f of state is pure and simple. You don't think about subscriptions or effects, you just describe what the UI should look like for a given state, and then library handles the rest. This is the beauty of T you already love. Implementation complexity. As you can see, the reactive approach requires more complex logic for handling lists. Creating, removing, and reordering items efficiently is not trivial. Yeah. The VDOM page function handles all of this for you. Construction. The VDOM approach keeps your entire view logic in one place, the view function. The reactive approach scatters it across multiple create effects calls, which can be added to reason about as the app grows. Yeah, performance. For 99% of applications, including a complex habit tracker, a good VDOM implementation like peakstreak is incredibly fast. The performance benefits of fine-grained reactivity only truly show in extreme edge cases, like thousands of data points updating 60 times per second. Yeah, that makes sense actually. Peakstreak, 5 stars. Are you trying to scam me? Are you trying to scam me too? What the hell is happening? Peakstreak, Jess. Wait a minute. Who is trying to scam me? Where's Peakstreak? Close, similar thing. Close, 0js, go bigger. It's empty, it's empty. Yeah. That's good. 9 years. Vintage. Wow. How JavaScript should be. Wow. Min.js, close. 12 years ago, wow. SRC. This $sign is so confusing. The smallest view library out there is probably HyperRep, only smaller is Peakstreak. Okay, it's super fine now. Absolutely minimal view layer for building web interfaces. Super fine is minimal view layer for building web interfaces in HyperRep without the framework. No state machines, effects, or subscriptions, just the absolute bare minimum. 1 kilobyte minified plus gzipped. Mix it with your favorite state management library or use it standalone for maximum flexibility. Here's the first example to get started right here. When describing how a page looks in Superfine, we don't write markup. Instead, we use h and text functions to create a lightweight representation of the DOM, or virtual DOM for short, of the DOM, and page to actually render the DOM. Where's page? Page. Okay, I see. So they fully render the app. So I have manually to check to choose what I want to page. Okay, next up, let's take a look at simple to-do app. You can only add across of to-dos with it. Can you figure out what's happening just by poking around the code a bit? Update volume. Okay. Add to-do. State to-do, concat, filter. Okay. Main, h2 to-do list. Yeah, I already seen that one, I guess. It's pretty good. Set state. How does this one work? Like, wait a minute. Pick a DOM, which is a virtual DOM rather than a full framework. For example, DOM is in there with the hyper family, not what I was thinking. Damn. Not what I was thinking of, but appreciate the suggestion. Maybe cell. Self-driving web app framework. Self-constructing web app framework powered by self-driving DOM. 7 years ago. Okay, crazy. Redom. They're all like extremely old. JS. Reddit. It's 7 years. Okay, anyway. Can this simple library handle routing? Yes, absolutely, and it can do so very elegantly. Routing is not a special magical feature, it's just another piece of application state. Here's how you integrate routing into a DOM-based RJS. Okay, the strategy state. The current URL path will be stored in your state. Okay, history API. We'll use the browser building history API and the post-state event to change the URL without a page reload. Okay, the view function will act as a reload rendering a different page component based on the Access navigate will be handled by an action that updates state road and calls history. Okay. I could not find Picodon. Are there... What are my options for small and efficient DOM? Actually, right now I'm thinking about just using HyperApp. Install.js. Hyperscript. Like, this one looks so good. It's so small. Okay, I don't need Elm for now. This direct successor of Superfine. This is the most direct answer to a question. Superfine is a spiritual successor created by the same author. It's designed for the exact purpose you have to be the tiny, fast, and simple DOM core. Okay, The rest of your app function is okay. Preact. Snap down. 1 kilobyte. It should be like so simple. I should be able to read it in few minutes, isn't it? Wait a minute. How's it called? Superfine? Probably yes. Preact. Superfine. Let's check it out. It's real. It's barely supported. Okay. Barely maintained. HyperApp. Even worse. Superfine JS. Index.js. Okay. Damn, it looks exactly the same as HyperApp. Wait a minute. Where was HyperApp? Index.js. They're like same. It's a start node, text node, empty object, empty array, listener, patch property. Wait, listener function event. This events, event type event. Okay, so we create function called listener. Who the fuck creates function in that way? That's like ridiculous. Why is there 1,000 ways to create function in JavaScript? Anyway, function takes event. So what are we doing? This events. Oh, it breaks my brain so hard. What is this? It's like just a variable. It's basically a function, isn't it? Does function have events in JavaScript? What is it? js.events. Okay, there's... never mind. Event type. Okay, let's just keep it. Get key, vidom. If vidom equals no, then vidom, else vidom key. Patch property, node, key, old value, new value, is SVG. Wow. If key equals key, else if key equals O, N, if not events or not events equals empty object, key equals new. What the hell is that? Remove event listener. Okay, I was so wrong. I cannot read it. Page note. Page note. All the kids. H text. So we are going way back right here. H page, we import our vidom tools. Okay, let's get to it, right? So I delete the front end completely. I'll not use Svelte, right? Probably not. Maybe no, I'll just move it for now because maybe I'll just hate the experience completely and I'll go back to Svelte. So let's check it out. Front end. My bad. What am I doing? Yeah, add front end. Lib.js, call it. Also, what if I want to use TypeScript? Do I have to use TypeScript? Probably want to. Maybe JS docs are enough. Let's just call it lib.js. Actually, I don't mind it. So basically, it creates app. And that's it. Only app. Then we got app state view node. Current state equals state. Old node equals no is rendering equals false. Dispatch. Action payload. Actions are functions that transform state. New state equals action current state payload. Okay, new state. If the action returned a new state, update and render. Okay, so it's constantly running, it's constantly checking if state has changed, right? Am I wrong? By each update they occur in the same tick. Okay, current state equals new state. If not, it's render and request animation frame. Where do we... Is it built-in function? You know what? I'll just import this one. npm install hyperapp. Actually, TypeScript. Oh, there's nothing said about TypeScript here. Let's just ask Gemini then. Can I use TypeScript? What is the best setup for such stack? Let's let him think. Clear. Frontend. Clear. Let's ban init. Blank React library. TypeScript. Types ban. Okay. Absolutely, using TypeScript is not just possible, it's the single best decision. I like this text is just so ridiculous. You can make to enhance the simple yet powerful and robust nature of the library design. It adds layers of documentation and error prevention that invaluable, especially as a project grows. The best setup for the stack is one that is fast, modern, and require minimal configuration. For this, there is clear winner white. I mean, yeah, white is good. White.js. White is actually pretty good. Oh, they got new page? Damn, it looks sick, not gonna lie. It lags a lot, but it looks sick. Like, I can't scroll it, it's just... FPS draws so hard. But yeah, it looks good. Okay, let's get started. Then I guess I'll have to remove everything. Wait a minute. Git ignore rem. Will it tell me how to install it? Yeah, it will. Ban, create, white, latest. Ban, create, white, latest, here. Vanilla, view, React, lead, svelte, solid, quick, angular, Marco, others. What is Marco? Oh, it's like the mix of all of them, right? If I'm not mistaken. Declare a HTML-based language that makes building web apps fun. Okay, so it's another language. Actually doesn't look that bad, but it's not what I need. Vanilla? Can I choose TypeScript? Yeah, I can. Ban install. Ban run dev. Okay. Create type library car. Okay, actually it's good enough for now. It's pretty late, I have to go sleep. And I'll proceed tomorrow.